Have you ever looked up at the night sky and wondered if we are alone? The universe stretches endlessly above us, filled with mysteries and possibilities that spark our imagination. Over the past few decades, astronomers have discovered thousands of exoplanets, planets that orbit stars far beyond our own sun. Each new discovery brings us closer to understanding our place in the cosmos. The number of known exoplanets is growing at an incredible pace, with over 5,000 confirmed so far, and more being added every month as our technology improves. Our galaxy, the Milky Way, is teeming with countless worlds, each one unique, each one holding its own secrets and stories waiting to be uncovered. With so many planets out there, you might expect that we'd have already found a solar system just like ours. A stable star, rocky planets close to the sun, and gas giants orbiting farther out, creating a familiar and orderly arrangement. But here's the mystery. Despite all our searching, we haven't found a true twin to our solar system. Not even one system matches our layout exactly. Instead, we've seen giant planets orbiting extremely close to their stars, wild and unpredictable planetary orbits, and even systems with two or more suns lighting up their skies. A familiar arrangement like ours, with its neat separation of rocky and gas planets, remains elusive and rare among the systems we've found so far. Why is our solar system's arrangement so rare? Are we truly unique in the galaxy, or have we simply not looked in the right way or deep enough yet? Our search tools are only now becoming sensitive enough to detect the subtle details of distant planetary systems, revealing new worlds that were once invisible to us. The quest for a cosmic twin is about more than just curiosity. It's about understanding our origins and our place in the vast universe. Every new exoplanet we discover adds another piece to the cosmic puzzle, teaching us more about how planets form, evolve, and sometimes even support life. While we haven't found our twin yet, the search is just beginning. Each discovery brings us closer to answering the age-old question: are we alone? The cosmos is unimaginably vast, and its secrets are waiting for us to uncover them, one discovery at a time. So let's dive in and explore this cosmic search together as we continue our journey to find our place among the stars. Our cosmic blueprint. When we gaze up at the night sky, we can't help but wonder, is there another solar system out there just like ours? The search for a true twin is one of the most fascinating quests in astronomy. What are we really searching for in a solar system twin? It's not just about finding another planet that looks like Earth. We're looking for an entire system that echoes the unique structure and harmony of our own. It's not just another Earth. It's a whole system that mirrors ours, with the right balance of planets, orbits, and cosmic ingredients. First, we need a star like our Sun, a G-type main sequence star, stable and not too hot or cold. This kind of star provides the steady energy needed for life to potentially develop and thrive. Next, the planets, small, rocky worlds like Mercury, Venus, Earth, and Mars close in, forming the inner solar system. These rocky planets are essential, as they offer solid surfaces and, in some cases, the right conditions for water and life. With gas giants like Jupiter and Saturn farther out, these massive planets play a crucial role in shaping the system's dynamics. This arrangement is crucial. Jupiter's gravity, for example, helps shield the inner planets from constant bombardment by asteroids and comets, acting as a cosmic protector. The orbits matter too. Our planets travel in nearly circular paths, all in the same flat plane, making the system stable and reducing the risk of catastrophic collisions. Many exoplanet systems have planets with wild, tilted, or oval-shaped orbits, leading to chaos and instability that could prevent life from ever taking hold. A true twin needs that same calm, predictable dance, a cosmic choreography that has lasted for billions of years. The ingredients count as well. The system must form from a cloud with similar chemistry to ours, rich in heavy elements to build rocky planets and provide the raw materials for life. Water and other life-friendly ingredients must be delivered to the right places, often by comets and asteroids in the early days of a system's formation. Finding a system with the right star, planetary layout, orbits, and ingredients is the ultimate goal for astronomers searching the galaxy. It's a very specific recipe, and so far, we haven't found another kitchen that's cooked it up just right. The universe is vast, but true twins seem incredibly rare. That's what makes the search so challenging and so exciting. Every new discovery could be the breakthrough we've been waiting for. Each discovery brings us closer to understanding if our solar system is one of a kind, or if there are others out there waiting to be found. The hunt continues as we refine what we're looking for and develop new tools to peer deeper into the cosmos. Will we ever find a true twin? That's the cosmic mystery that keeps us searching, always looking for another place that feels like home. How do we find planets light years away from Earth, orbiting stars so distant that their light takes centuries to reach us? We can't just snap a picture. Exoplanets are incredibly tiny and faint compared to the blazing stars they orbit. The glare from their stars overwhelms any direct image we might try to capture, making these distant worlds almost invisible to our telescopes. That's why astronomers have developed clever, indirect methods to hunt for these hidden planets, relying on subtle clues in the starlight. The most successful is the transit method, watching for tiny, regular dips in a star's brightness as a planet passes in front of it, blocking a fraction of the light. Like a moth crossing a streetlight, the planet briefly blocks a bit of the star's glow. This not only reveals the planet's size and orbit, but can even hint at the presence of atmospheres or clouds if we look closely enough. This method, used by space telescopes like Kepler and TESS, has already discovered thousands of exoplanets, revolutionizing our understanding of the galaxy. Another key technique is the radial velocity or wobble method, which looks for tiny shifts in a star's motion caused by the gravitational pull of an orbiting planet. A planet's gravity tugs on its star, making it wobble ever so slightly. Astronomers detect this by measuring subtle changes in the star's light spectrum over time, revealing the presence of unseen worlds. Both methods are best at finding big, massive planets that orbit close to their stars, since they block more light or cause bigger wobbles, making them easier to spot with our current technology. That means we mostly see the biggest, hottest, and closest planets first, while smaller, more distant worlds remain hidden. Our tools are powerful, but they give us a skewed, incomplete view of the galaxy's true diversity. There are likely countless planets we haven't found yet. The real challenge is spotting smaller, Earth-like planets farther out, which produce only the faintest signals, barely detectable with today's instruments. As our technology improves with new telescopes and more sensitive detectors, we'll get a clearer, more complete picture of what's really out there among the stars. For now, we're seeing just the tip of the cosmic iceberg, an exciting glimpse with so much more waiting to be discovered in the vastness of space. Our planet hunting tools are amazing, but they have big limitations. The transit method only works if a planet's orbit lines up perfectly with our view. Odds are about 1 in 200 for an Earth-like planet. Confirming a planet like Earth means waiting years for repeated transits. For a Jupiter-like planet, it could take decades. The radial velocity method favors massive planets. Earth's tiny wobble is barely detectable. Our solar system's stability, small rocky planets, distant giants, makes it hard to spot with current tools. We're searching for a quiet, subtle system in a universe full of loud, obvious ones. The very things that make our solar system life-friendly also make it nearly invisible to our current methods. That's why finding a true twin is so tough. But with patience and better technology, we're closing in. The exoplanets we've found reveal a wild diversity. Most systems look nothing like ours. Hot Jupiters, for example, are giant planets orbiting scorchingly close to their stars, nothing like our distant Jupiter. Many systems have super-Earths or mini-Neptunes, planets larger than Earth but smaller than Neptune, packed tightly near their stars. Some, like TRAPPIST-1, have multiple rocky planets crammed closer than Mercury is to our Sun. We've found planets on wild oval orbits, and even worlds orbiting 2 stars at once. This cosmic zoo shows that planetary systems form in many ways. Our solar system's calm, spacious layout might be rare, not the norm. The more we discover, the more we realize nature is far more creative than we imagined. Are we searching in the right places? Most exoplanet hunts focus on red dwarfs, small, dim stars that make planet detection easier. Red dwarfs are common, but their planets orbit close in, often tidally locked and blasted by stellar flares, not much like our solar system. To find a true twin, we need to look at Sun-like G-type stars. This is harder and takes longer, but new technology is making it possible. Our searches have also covered only a tiny part of the Milky Way. The galaxy's chemical makeup varies, and rocky planets need heavy elements. Some regions may be better for solar system twins. We're just starting to explore the right stars and neighborhoods. The twins we seek may be waiting in unexplored corners of the galaxy. The search is only beginning. The star is the heart of any solar system twin, and our sun is special. It's a G-type Goldilocks star, not too big, not too small, and very stable. Massive stars burn out quickly and explode, while red dwarfs are long-lived but come with flares and tidal locking. Our sun's habitable zone is wide and comfortable, allowing for stable climates and regular day-night cycles. Its calm nature gives life time to evolve. G-type stars are only about 7% of the Milky Way stars. Finding one with the right age, stability, and planetary system is rare. The search for a solar system twin is really a search for another Goldilocks star. That's what makes the hunt so challenging and so important. Our sun's unique qualities may be the key to why we're here. Finding another like it could change everything. Why do we care about finding a solar system twin? It's about more than just planets. It's about understanding ourselves. If systems like ours are common, Earth-like worlds could be everywhere, raising the odds for life. A twin system with a rocky planet in the habitable zone would be a prime target for searching for biosignatures, signs of life. Studying twins at different ages helps us understand our own solar system's past and future. It's like seeing other families to learn about your own. The search connects to our deepest questions. Are we typical or a cosmic fluke? If we're one of many, we're part of a larger galactic story. If we're rare, it highlights how precious our world is. Either way, the answer will reshape our view of ourselves. The quest isn't just about other worlds, it's about our own place in the cosmos. That's why the search matters. The search for our solar system twin is about to get a major upgrade. New telescopes on the ground and in space will detect smaller planets and study stars for longer. The extremely large telescope and Giant Magellan Telescope will spot tiny wobbles from Earth-sized planets. They may even directly image distant gas giants like our own. In space, missions like Plato will search for Earth-sized planets around sun-like stars, watching for years at a time. NASA's Habitable Worlds Observatory aims to directly image Earth-like planets and search their atmospheres for life. We're moving from just finding exoplanets to truly understanding them. Every discovery refines our search and brings us closer. With patience and new technology, finding our solar system's twin feels closer than ever. And when we do, it will be one of humanity's greatest discoveries.